डियर स्टूडेंट्स, आज हम फॉर्मेट्स थ्योरम की स्टडी करेंगे। फॉर्मेट्स थ्योरम का स्टेटमेंट है, इफ P इज प्राइम एंड A is any integer, then A raised to the power P is congruent to A mod P. First of all, let G be the set of non-zero residue class of integers modulo P. हम G को इस प्रकार का सेट डिफाइन कर लेते हैं जिसके मेंबर्स प्राइम P के लिए रेसिड्यू क्लास का सेट है। क्रॉस P मल्टीप्लिकेशन मॉडुलो P के लिए कंपोजिशन हम जानते हैं कि क्लास जिसके मेंबर्स P-1 है G मल्टीप्लिकेशन मॉडुलो P के लिए एक ग्रुप बनाता है। So friends, here P is prime and this class 1 is the identity in Z. According to this theorem, A is any integer, so let A be any integer, and this P is prime, this one, and now there are two cases arises. Either P is divisor of A, if P is divisor of A, फॉर एग्जाम्पल आप इस बात को यूँ समझ सकते हैं कि 3 is the divisor of 12 or 9. So 9 multiplied by 9 P टाइम्स अगर हम करें तो this 3 is again divisor of this one. So if P is the divisor of A, then P is the divisor of A raised to the power P also. And in this example, if P is the divisor of 9 raised to the power P, it means also divisor of -9. That is, we can say that P is divisor of A raised to the power P minus A also. But you know, if N is the divisor of A minus B, then this means A is congruent to B mod N. So by this result, this P is the divisor of A raised to the power P minus A can be written as A raised to the power P is the congruent to modulo is congruent to A modulo P. So this is our result when P is the divisor of A. Second, if P is not divisor of A, yes, second, P is not divisor of A. here class A is not equal to 0 class, because if class A is equal to class 0, you know that if class A equals to class B, then A is congruent to B modulo N. So by this definition we can write, if class A is equal to class B or 0, then this A is congruent to 0 mod P, 0 modulo P. And this gives this P is the divisor of difference of A and 0, that is P is the divisor of A. But हमने माना है कि P is not divisor of A, and if we let A class equals to class 0, then P is the divisor of A. So this is contradiction. So we can say that if P is not divisor of A, then class A not equal to class 0. And if class A is not equal to class 0, it means this A is the member of this C. So A is the member of Z. You know, by Lagrange's corollary, if A is the member of Z and the order of Z is n, then A raised to the power n is identity. So by this corollary, here A is the member of Z and 1 is the identity in Z. So A raised to the power order of Z equals to identity 1, and this can be but order of G is P minus 1. Here order of G is P minus 1, member of P minus 1. This is last member. 1, 2, 3 class P minus 1 means order of G is P minus 1. So for this order of G we can write P minus 1, and by the definition of class power rule, this class is P minus 1 times equals to class 1, and by the definition of product of class A and B equals to product of integers, class of product of integers. Say this can be written as A cross A cross A, and this is A raised to the power P minus 1 equals to 1, and two classes are equal की परिभाषा क्या है? class A equals to class B if and only A is congruent to B modulo P. So by this definition, A raised to power P minus 1 is congruent to 1 modulo P. So this gives you know this one, and you know if A is congruent to B mod n, then n is the divisor of difference of A and B. So you can write here P is the divisor of difference of A minus B and 1. This one. And if this is multiplied by A, then also P is the divisor of this one. It means P is the divisor of A raised to power P minus 1 minus A, and this gives A raised to the power P is congruent to A mod P. This one. So in both cases, already here A raised to power P is congruent to A modulo P if we take P is the divisor of A, and if P is not divisor of A, then also we have, in both cases, we have E raised to the power P is congruent to A mod P. This is our Fermat's theorem. So friends, इससे पहले हमने आइलर्स थ्योरम देखा और दिस इज फर्मेट्स थ्योरम. नाउ theorem number 8. If H is a subgroup of group G and A, B are two members of G, then HA equals to HB, means two identical right cosets gives AB inverse is the member of H. Also left cosets AH equals to BH implies if and only if B inverse A is the member of H. First हम HA equals to HB लेते हैं, तो HA equals to HB B से इनवर्स से पोस्ट ऑपरेट करने पर इस B और B इनवर्स को एसोसिएट करने पर दिस विल बी आइडेंटिटी. दिस B इनवर्स B इज आइडेंटिटी and then HE is H. So we get HAB inverse is H. But you know E is the member of HA. In similar way, you can say that AB inverse is the member of HAB inverse. But we prove that HAB inverse is H. So this HAB inverse is H, and this gives AB inverse is the member of H. तो ये हमें इसमें प्रूव करना था. AB inverse, if HA equals to HB, then AB inverse is the member of H. विलोम कन्वर्स पार्ट लें, कंडीशन इज सफिशिएंट लें, तो here AB inverse is the member of H, और हमें यहाँ प्रूव करना है HE equals to HB. तो if AB inverse is the member of H, then by the definition of right coset, AB inverse B is the member of right coset HB. And now associate these two. This is identity E, and we know that AE is A. AE is दोबारा देखिए इसको. A is the member of दोबारा देखिए इसे. AB inverse is the member of H, यहाँ given है. Also we know that AB inverse is the member of HAB inverse, because you know that A is the member of right coset HA. It means AB inverse is the member of right coset HAB inverse. So, but this shows that AB inverse is the member of H, and AB inverse is the member of HAB inverse also. It means intersection of H and HAB inverse is not equal to equality set. Means H and HAB inverse are not disjoint, and if they are not disjoint, then they are identical. पहले किसी थ्योरम से हम जानते हैं कि या तो डिस्जॉइंट होते हैं टू राइट कोसेट्स, या फिर आइडेंटिकल होते हैं. सो दीज आर नॉट डिस्जॉइंट. इट मीन्स HAB इनवर्स एंड H आर आइडेंटिकल, मीन्स इक्वल. और अब यहाँ B से पोस्ट ऑपरेट करने पर, और यूँ कह सकते हैं कि HAB इनवर्स B इज HB, इनको एसोसिएट करते हैं तो B इनवर्स B इज आइडेंटिटी, दिस वन इज आइडेंटिटी E, एंड अगेन AE is A. So HA equals to HB. So if AB inverse is the member of H, then HA equals to HB. ये हमारा विलोम पार्ट है इस थ्योरम का. तो फ्रेंड्स, आज आपने फर्मेट्स थ्योरम और एक ये थ्योरम इम्पोर्टेंट रिजल्ट. In similar way, you can say that if AH equals to BH, then B inverse is the member of B inverse A is the member of H प्रूव कर सकते हैं. Again, next theorem, the relation of congruence in a group G is defined as A is congruent to B mod H if and only if B inverse is the member of H, then is equivalence relation. तो हमें यहाँ दिया हुआ है कि if H is the subgroup of group G and relation for two members A and B in G, A is congruent to B modulo H is defined as AB inverse is the member of H is equivalent relation. और इक्विवेलेंस रिलेशन होने के लिए तीन प्रकार के रिजल्ट रिफ्लेक्सिव, सिमेट्री एंड ट्रांजिटिव आपको प्रूव करना होगा. यू नो किसी रिलेशन के लिए रिफ्लेक्सिव होने के लिए ए रिलेटेड टू ए तो वह रिलेशन रिफ्लेक्सिव होता है. सेकंड, इफ ए रिलेटेड टू बी देन बी रिलेटेड टू ए हो तो सिमेट्रिक होता है. थर्ड वन, इफ ए रिलेटेड टू बी एंड बी इज रिलेटेड टू सी देन ए रिलेटेड टू सी हो तो वो रिलेशन ट्रांजिटिव होता है. ये तीनों बातें यहाँ जो डिफाइंड रिलेशन है, A इज कॉन्ग्रुएंट टू B मोडुलो H के लिए ए बी इनवर्स बिलोंग्स टू H है, उसमें लागू होती है. वो यहाँ आप आसानी से देख सकते हैं. इस प्रूफ में फर्स्ट ए इनवर्स इज द मेंबर ऑफ H एज आइडेंटिटी. सो A related to A by this definition, A is congruent to B mod H if and only if AB inverse is the member of H. तो यहाँ अगर A inverse लिखते हैं तो this one is A, so this is symmetric. Second, reflexive, this is reflexive. Second, symmetric. मान लेते हैं कि ये इज कॉन्ग्रुएंट टू बी mod H, देन ए बी इनवर्स इज द मेंबर ऑफ H, इनवर्स आल्सो मेंबर ऑफ H, और बाय रिवर्सल लॉ दिस वन, और बी ए इनवर्स इज बाय दिस डेफिनेशन हियर बी हियर ए मीन्स बी इज कॉन्ग्रुएंट टू ए, सो दिस इज सिमेट्रिक आल्सो. थर्ड वन इज ए इज कॉन्ग्रुएंट टू बी एंड बी इज कॉन्ग्रुएंट टू सी, देन फर्स्ट गिव्स ए बी इनवर्स इज द मेंबर ऑफ H, सेकंड गिव्स बी सी इनवर्स इज द मेंबर ऑफ H. So by closure property, AB inverse BC inverse is the member of H. And this gives एसोसिएट बी इनवर्स बी को करने पर दिस विल बी आइडेंटिटी एंड ए ई इज ए, सो दिस इज ए सी इनवर्स द मेंबर ऑफ H, इट मीन्स ए इज कॉन्ग्रुएंट टू सी, so transitive. So this relation is here on this relation is reflexive, symmetric and transitive. So this is equivalence relation. This is equivalence relation. कोई रिलेशन मतलब रिफ्लेक्सिव, सिमेट्रिक और ट्रांजिटिव होता है तो वो आपको यहाँ 3 बातें सिद्ध करनी पड़ेंगी इसके लिए. नाउ नेक्स्ट टर्म. नेक्स्ट इज H is a subgroup of group G and HA is the right coset of H in G. Also CA is the class of A whose members are of G such that the member that is congruent to A modulo H वो class of A यहाँ defined है. तो here we have to prove class A is equals to right coset of H. इसके लिए फर्स्ट कोई मेंबर X CA का ले लेते हैं. जैसे X is the member of CA, then X is congruent to A mod H. By this definition, XA inverse is the member of H. So this gives XA inverse A is the member of H. And by associativity and existence of identity, inverse and identity, we have this is X. So X is the member of HA. So if X is the member of class A, then X is the member of HA. This gives CA is the subset of HA. Again, let X is the member of HA now. Then there exists H in set H such that X equals to HA, and this gives A inverse a post operator neighbor. XA inverse equals to H, but this H is the member of set H, so this XA inverse is the member of H, and when XA inverse is the member of H, it means X is congruent to A modulo H by the definition of congruence relation. And if X is जो इस शर्त का पालन करते हैं, X is congruent to A modulo H, ये देखिए वो मेंबर जो G का है CA का होगा. सो दिस X is the member of CA. सो हमने क्या पाया कि each X which is the member of H is the member of CA. So each X member of H is the member of CA gives this HA is the subset of CA. ये दो रिजल्ट CA equals to HA को व्यक्त करते हैं. Here HA is the subset of HA and HA is the subset of CA. It means CA equals to HA. This is our theorem. One definition more here. Index of a group subgroup. You know, by Lagrange's theorem, order of G equals to k times order of H. हमने Lagrange theorem देखा कि order of H is the divisor of order of G, जिसमें हमने देखा था k डिस्जॉइंट लेफ्ट कोसेट्स की संख्या है. सो दिस k इज क्या है? असंयुक्त वाम सहसमुच्चय की संख्या. वही H का G में इंडेक्स कहलाता है. तो दिस इज द डेफिनेशन ऑफ इंडेक्स ऑफ H इन G, and it is denoted by G like that, denoted by this symbol, and this is K is equals to order of G or order of H. This is index. Order of G or order of H is the index of H in G. This is the definition. हमारे सबसे पहले हमने एग्जाम्पल दिया था 4Z का. उसमें राइट कोसेट्स डिस्जॉइंट थे 4Z, 4Z + 1, 4Z + 2, 4Z + 3, जिनकी संख्या 4 है. इसका अर्थ ये हुआ कि 4Z का Z में इंडेक्स 4 है.